Okay guys, so today we're looking at understanding and calculating compound interest. So why is compound interest essential? So we've already looked at simple interest in the previous section. More commonly though, interest is added to the account at the end of each time period, and I'm going to show you what I mean. So future interest calculations are then made on the new balance, and that includes any previous interest payments, and then the interest compounds, and that's why we call it compound interest, and I'll show you what I mean. So if you've got $100 and you put it into the bank at 1.1%, at the end of the year, say it's on a yearly rate, you're going to have $110. So then you take that 110, you put it back into the bank at 1.1, you've now got $121. You put that back into the bank for the next year. You see how your $100 has grown and grown and grown and grown. So this is called recurrence relation, which compound interest is just one type. In this course, what we're going to do is we're going to show you a formula, which is going to help you to do it. So let's look at it first of all in table form. Consider investment of $2,000. So you get $2,000, you put it in an account, which is paying 4% per annum, which is per year, for 3 years. You have to leave it in there. With the interest is added to the account at the end of each year. Right, so first year, $2,000. You got your $2,000, you times it by 4, divided by 100, and you get $80. So we add our $80 on and we get $2,080. So the second year, we now start with $2,080. We do the same calculations, we're making $83.20. So at the end of the year, we've got $2,163.20. We stick that back in for the third year, work it all out, we make $86.53. So actually in total, we've now got $2249.73. So consider an investment, have we already said that, but you can use the table, yes. So notice the balance becomes the principal in the next line. So that becomes what you start with, your P. And that the principal is multiplied by this 4 over 100 each time, the same time, because it's the same interest rates. Okay, so this is called the recurrence relation. So when something recurs, it takes place again and again and again. Here we're multiplying the starting principal by repeating the multiplication, so we've repeated it, to the number of time periods. So for 3 years, we did it once, we did it twice, we did it 3 times. So we can use indices, which is powers, to write the repeated or the recurring multiplication. So after 3 years, your balance was 2,000 times 1 plus 4 over 100 to the power of 3. And you would get the answer straight away. So if you went 2,000, which is what you started, times 1, put in brackets, 1 plus 4 over 1,000 to the power of 3. So you would actually put that into your calculator as that. All right, so now let's look at an example. So Titan invests $900 in an account paying 3% per annum for 4 years. Okay, so we start off, complete the following table. So we go, principal was 900. So we've got to work out his interest. We times it by 3 over 100. We get $27. We add that to our 900. We've got 927. Now our next year, our principal is 927. We times that by 3 over 100 and we make $27.81. We add that to our 927 and we've now got $954.81. That becomes our principal. We then work out what our interest is going to be, $28. We add it on, we've got 983, that becomes our new principal. Work it out, so it comes $29.50. We've now got $1,012.95. Right, so you've done what they've asked, calculate the balance, and we've done 4 times because it's 4 years. Then B says, how much interest did he earn? Well, he started with 900 and he ended up with 101,295. So we go 101,295, take away 900 is 112.95. And that would be the answer. All right, so I want you to try and do some of these for me now.